Now, biology uses like a multi-scale competency architecture, meaning that every level has goals. So molecular networks have goals, cells have goals, tissues, organs, colonies, and it's the interplay of all of those that enable biology to solve problems in new ways. So evolution is very good at this agential bioengineering, right? When evolution is discovering a new way of being an animal, an animal or a plant or something, sometimes it's by changing the hardware, changing protein structure and so on. But much of the time, it's not by changing the hardware, it's by changing the signals that the cells give to each other. It's doing what we as engineers do, which is try to convince the cells to do various things by using signals, experiences, stimuli. That's what biology does. It has to, because it's not dealing with a blank slate. Every time, if you're evolution and you're trying to make an organism, you're not dealing with a passive material that is fresh and you have to specify. It already wants to do certain things. So the easiest way to do that search to find whatever is going to be adaptive is to find the signals that are going to convince cells to do various things. You can change the huge amount of information in the genome that isn't structural at all. It's signaling. It's when and how do cells say certain things to each other, and that can have massive changes as far as how it's going to solve problems. And engineering is the right perspective on all of this stuff because it gets you away from subjective terms. People talk about sentience and this and that. Those things are very hard to define. People argue about them philosophically. I think that engineering terms like competency, like pursuit of goals, right? All of these things are empirically incredibly useful because you know it when you see it, and if it helps you build, right? If I can pick the right level, I say. This thing has, I believe this is X level of competency. I think it's like a thermostat, or I think it's like a better thermostat, or I think it's various other kinds of many different kinds of complex systems. If that helps me to control and predict and build such systems, then that's all there is to say. There's no more philosophy to argue about. So I like competency in that way because you can quantify. You have to make a claim. Competent at what? And then, or if I tell you it has a goal, the question is what's the goal and how do you know? And I say, well, because every time I deviated from this particular state, that's what it spends energy to get back to. That's the goal, and we can quantify it and we can be objective about it. And the reason robots don't get cancer is because generally speaking, with a few exceptions, our architectures have been, you've got a bunch of dumb parts, and you hope that if you put them together, the overlying machine will have some intelligence and do something or other, right? But the individual parts don't care. They don't have an agenda. Biology isn't like that. Every level has an agenda, and the final outcome is the result of cooperation and competition both within and across levels. So for example, during embryogenesis, your tissues and organs are competing with each other. And it's actually a really important part of development. There's a reason they compete with each other. They're not all just, helping each other. They're also competing for information, for limited metabolic constraints. What happens here is that each level bends the option space for the level beneath so that your parts basically they don't see the geometry. So I'm using and I think I take this seriously. Terminology from relativity, right? Where the space is literally bent. So the option space is deformed by the higher levels, so that the lower levels, all they really have to do is go down their concentration gradient. They don't have to. In fact, they can't know what the big picture is. But if you bend the space just right, if they do what locally seems right, they end up doing your bidding. They end up doing things that are optimal in the higher space. Conversely, because the components are good at getting their job done, you as the higher level don't need to try to compute all the low-level controls. All you're doing is bending the space. You don't know or care how they're going to do it. I had this hypothesis that I thought actually the system is probably more intelligent than that. So what did we do? We made what we call Picasso tadpoles. So everything is scrambled. So the eyes are on the back of the head, their jaws are off to the side, everything is scrambled. Well, guess what they make? They make pretty normal frogs because all the different things move around in novel paths configurations until they get to the correct froggy, sort of frog face configuration, then they stop. So the thing about that is, now imagine evolution, right? So you make some sort of mutation, and it does, like every mutation, it does many things. So something good comes of it, but also it moves your mouth off to the side, right? Now, if there wasn't this multi-scale competency, you can see where this is going. If there wasn't this multi-scale competency, the organism would be dead. Your fitness is zero because you can't eat, and you would never get to explore the other beneficial consequences of that mutation. You'd have to wait until you find some other way of doing it without moving the mouth. That's really hard. So the fitness landscape would be incredibly rugged. Evolution would take forever. The reason it works, well, one of the reasons it works so well, is because you do that. No worries, the mouth will find its way where it belongs, right? So now you get to explore. So what that means is that all of these mutations that otherwise would be deleterious are now neutral, because the competency of the parts make up for all kinds of things. So all the noise of development, all the variability in the environment, all these things, the competency of the parts makes up for it. Every component has its own goals in various spaces, usually with very little regard for the welfare of the other levels. So as a simple example, you as a complex system, you will go out and you will do, jujitsu or whatever. You'll have you go rock climbing and scrape a bunch of cells off your hands, and then you're happy as a system, right? You come back and you've accomplished some goals and you're really happy. Those cells are dead. They're gone, right? Did you think about those cells? Not really, right? You had some bruising. So that's the thing to remember, is that and we know this from history, is that just being a collective isn't enough.